The topic of today's technical session is structural rehabilitation in MES and a case study of KV school. This topic is very much relevant in MES because at most of the locations we see spalling of concrete in slabs, columns and RCC structures. So the sequence of this technical session will be the changes which are implemented in IS 456, definition and requirement of rehabilitation, steps of rehabilitation, case study of KV building and the conclusion. IS 456. The revision of IS 456 was done in 2000 and reaffirmed in 2021. In this revision, weightage to one good quality of the concrete, that is durability, is given. This quality of concrete was earlier ignored before 2000. The various factors which were brought out by IS 456 2000 which affects the durability are environment. If the environment is having chlorine content like in coastal areas, it is categorized as sewer. Cover to concrete, the most neglected aspect in past. In the revision, the cover requirement is increased, quality and type of constituents. If the constituents of the concrete such as sand has chlorine or sulfates, then this results in compounds which have higher volume, so they expand and result in spalling. Cement content and water cement ratio. This is the most important ratio which governs both strength and durability of concrete. So we should keep water cement ratio to minimum. To do this, nowadays lot many admixtures are available in market. These admixtures lower down the water cement ratio and ensures workability of concrete also. Workmanship. Workmanship, nowadays various mechanical means are available which with low workability concrete can also achieve the finish. Grade of concrete. The minimum grade required as per revision of IS 456 is now M20 instead of M15 which was in past. Shape and size. It is a duty of the structural designers and architects to pay attention to the design of the structure so that water deposition doesn't occur there. As we are all aware that in the coastal environment, the life of the structure reduces significantly to the tune of 60%. For steel structures, it reduces from 25 years to 15 years, masonry structure 30 to 25 and RCC structure 50 to 30 years. With my past experience at Air Force Station Thane, I was looking after all the pockets of Mumbai. Problem is common in all the pockets. The structure vintage is of 1960 to 90. 1960s structure were of masonry. They were not showing any signs of deterioration due to corrosion of steel, but the structure, framed structures which were made 80 to 90, these were not complying the durability requirement because they were not existing at that time. Hence, due to the corrosion of steel, spalling of concrete is observed in majority of the columns and beams. There are two terms, retrofitting and rehabilitation, which are used in conjunction by most of the engineers, but we need to differentiate in between the two. When the structure is made stable towards the forces for which it is not initially designed, it is known as retrofitting. However, when the structure's initial strength is restored, it is called rehabilitation. For example, this cylinder is standing. If this cylinder develop holes in it, then repairing those holes is termed as rehabilitation. However, tying the cylinder on all the four sides so that it doesn't fall against the lateral forces is a kind of retrofitting. So, if we are strengthening the structure against seismic forces for which it is not designed earlier, it is retrofitting, otherwise rehabilitation. Rehabilitation of a structure is need of the hour in MES and other government departments. Ideally, rehabilitation should be done in time when the structure is showing the signs of distress such as cracks, deflection before its design life. This rehabilitation will replenish the life by more 5 to 10 years at a less economic cost. In coastal areas where the relative humidity is more than 50%, carbonation of concrete occurs at a fast rate, reducing the pH of concrete less than 7, which leads to corrosion of steel and consequent spalling and deterioration of structure. At G Air Force Thane, we were having works of about 5 to 6 crores of this nature to gain this experience. So, we go through the procedure, what will be the steps to carry out rehabilitation of a structure. First step, loose concrete or plaster removal. Engineers need to do the visual inspection of problematic area, do technical inspection using NDT testings, decide whether rehabilitation need to be carried out or not, and if the answer is yes, then all the loose concrete and plaster need to be removed carefully. After the removal, step 2 comes removal of rust. Removal of rust need to be done with wire brush. Chemical which we used is Fuvert is applied on the rusted reinforcement, which after a curing period of 6 to 8 hours form corrosion resistant insoluble adherent layer on reacting with oxygen. Step 3. Anti-corrosive coating, which is a epoxy based adhesive, is done on the surface of the reinforcement. In our case, it is IPNet RB. After curing of 48 hours with air, it is finalized. Now, before the application of this anti-corrosive coating, all the corroded steel need to be replenished. These coatings usually come in 2 parts which need to be mixed and then applied. Structural defects in slabs and beams can be minor or major. For minor structural defects, we need to mix polymer latex additive to the plaster, in our case which was monobond. This imparts good flexural and tensile properties to plaster, low permeability and more impact resistance and bonding. The dosage of this chemical is about 10 to 15% in plaster, and in case of minor repairs, this with 1:3 mortar can be applied at the affected locations. Where the distress is more, that need to be repaired with micro concreting. Now, the micro concreting is a special kind of self-flowable concrete which attains the strength of 45 Newton per mm square in 7 days. So, we need to just provide the shuttering around the affected area, pour the concrete, cure it, and it's done. It is used in case of heavily damaged structural members such as columns and beams. Once the micro concreting is done, then the step comes leveling. This leveling chemical which we used is RNM leveling mortar. It is applied to fill pinholes and irregularities of micro concreting. After this, step 7 of priming comes, where a epoxy resin based primer is provided to give the surface for epoxy adhesive. Step 8, epoxy adhesive. We use RNM Matrix 20. It is a epoxy based adhesive which saturates carbon fiber to transform it into a high strength reinforced polymer. Step 9, which is important, carbon fiber wrapping. Carbon fiber is a special kind of fibers which are thinner than hair. These has the strength of 3500 to 4000 Newton per mm square, which is 6 to 7 times more stronger than steel. These are wrapped around the tensile members like column, beam and junctions. We need to first identify the column and beam where this carbon fiber wrapping need to be done. In our case, we have done the wrapping of joints which are critical and heavily damaged columns. Carbon fibers wrapping is very effective. When you wrap a 300 mm standard cylinder with carbon fiber, then its strength goes to 3 times. One more product which is available in market is carbon fiber laminate. Though this product is hardly used in MES works, but this is a sort of ply made up of carbon fibers which is provided in high tensile members such as beams of the flyovers. Once the carbon fiber wrapping is done, then the appearance of the column and beam need to be resorted to the other structural members with plaster on them. So, these carbon fiber surfaces are applied with epoxy adhesive on which the quartz sand is sprinkled, and in step 11, polymer modified plaster is done to give it the same finish as the regular plaster. These are the steps in which the rehabilitation of the structural members is complete. The most common rehabilitation issue which we face is of the slabs. So, first, if the slab is showing small areas of corrosion in reinforcement, then that small area can be repaired with monobond plaster which is applied in case of minor repairs. But if the concrete strength is lost, then grouting is the solution. You need to grout that concrete with epoxy based chemicals and the thickness of repair comes out to be more than 20 to 25 mm, then the answer is micro concreting. You need to place the shuttering below the slab, puncture the hole from top and pour the micro concreting. In our station, we had an incidence of one balcony falling from the top, and on inspection we found that 8 balconies are showing the similar signs of distress. So we provided vertical supports with neoprene bearings so that it only transfers vertical load, not movements. A case study of Kendra Vidyalaya need to be discussed here, which will tell us how a rehabilitation case should be assessed by the engineer and how need to be finalized. While doing the visual inspection of this KV building, you can see there are cracks in column to the tune of 3 to 4 inches. There are vegetation in all the shafts. All the sunken slabs are wet. All the chhajjas are showing cracks due to reinforcement corrosion. There is efflorescence in walls, in floors, cracks in masonry walls. Against this visual inspection, we all can assess that the building is in distress. So we decided to carry out the rehabilitation study of this building. That is started with NDT testing. We did rebound hammer, ultrasonic pulse velocity, carbonation depth and corrosion test by half cell potential meter. The results of this test have shown that the grade of concrete is near to M20. The site visit is conducted by the structural engineer. He noticed the location of all columns and beams and noticed these important points that this is a 4-story building. The length of the building is 54 meters and still no expansion joints are provided. M20 concrete is considered for 3 stories and for the 4th story it is reduced to M15 because there are majority of the cracks which are noticed. Beam sizes are sufficient, so in modeling nominal reinforcement is given and this building is not designed for lateral seismic forces. The interaction ratio diagram of the structure floor wise is shown here for dead load and live load. On the left hand side you will see the interaction ratio without rehabilitation, on right hand side with rehabilitation. So you will see that on the 4th story all the columns on the edge are failing. To restore them, we have increased the grade of these columns from M15 to M30 by application of carbon fiber and micro concreting, and we did micro concreting to all the cracked columns. However, in seismic analysis all columns were failing, so we provisioned shear walls to arrest the lateral forces. The analysis interpretations are as follows. Since the 3rd floor are severely cracked, grade reduced to M15 and 35% steel is considered corroded, so they are failing. Hence, we repaired them with micro concrete and carbon fiber. Now the building is safe for dead load and live load. After this, for retrofitting, we need to incorporate shear walls, after which we were able to make the building safe for seismic forces also. Cost aspect. The most important aspect which need to be studied before taking any engineering call. The BOQ is separately prepared for rehabilitation and retrofitting. The rehabilitation cost was coming 1.9 crore rupees. The retrofitting cost was coming 3.5 crore rupees. Since the aesthetics of the school were old and deteriorated, that is coming to 3 crore rupees, mounting to about 7 to 8 crores of expenditure. Though the life of the rehabilitation is only 10 years, so it is not wise to spend so much of money when we can get a new construction in 10 crores with 40 years life, complying all seismic requirements. So the conclusion of the case study is we went for the rehabilitation for a cost of only 67 lakh rupees to attend issues which need immediate attention, and we decided to go for a new construction of a building parallelly so that this old building can live up for 3 years and simultaneously a new building can come up in 3 years. Conclusion of this technical session is rehabilitation has carved a niche for itself in MES and other government department. Economic analysis is very much required before invoking any rehabilitation work. Good practices such as cover, high grade concrete, corrosion resistant steel need to be incorporated in works. Preventive maintenance to maintain life of structure should be done. Should do minor rehabilitation in maintenance to obviate major rehabilitation. A stitch at times saves 9. MES and user need to mutually decide whether we have to do the rehabilitation of a structure or can go ahead with the demolition of the same. I would like to conclude the session with a quote. Rehabilitating old homes is not about making them look new. It is about making new ones unnecessary. Thanks a lot.